Hello everyone, I'm Sharon Yu Siang Wong, a third-year biochemistry student from University Malaya. Today, I'm going to talk about cancer drug resistance, specifically exploring the mechanism behind resistance to the powerful chemotherapy drug, Doxorubicin. To begin, let's understand the concept of cancer drug resistance. Think of chemotherapies as a powerful warrior fighting against cancer cells. Resistance arises when these cells develop strategies to withstand therapeutic drugs, hindering their effectiveness and evolving forward adapting to the assault of its adversary. Now, let's talk about Doxorubicin, a potent anthracycline chemotherapy drug that has played a crucial role in cancer therapy for the past 3 decades. By inhibiting the enzyme topoisomerase II, crucial for cell division, Doxorubicin has been widely used in treating virus cancer, establishing itself as a frontline agent in the oncology arsenal. Despite its effectiveness, the utilities of Doxorubicin is constrained by severe side effects and toxicity. Administered intravenously, Doxorubicin has been instrumental in treating cancers such as breast cancer, leukemia, and lymphomas. However, this brings us to a crucial point. Understanding the mechanism behind Doxorubicin resistance is essential for overcoming challenges and enhancing drug therapeutic potential. One important mechanism in the Doxorubicin resistance is the reduced accumulation of the drug within the cancer cell. Efflux pump, specifically those from ATP binding cassette, ABC family, acts as cellular gatekeeper, actively pumping Doxorubicin out of the cancer cells. This limits the drug's concentration, diminishing its therapeutic impact. Moving on to DNA repair, Doxorubicin inhibits topoisomerase II, causing DNA damage. In resistance to cancer cells, there can be upregulation and mutation in topoisomerase II, allowing these cells to continue functioning despite the DNA damage induced by Doxorubicin. It's like the cancer cells have their repair crew working overtime. Apoptosis, the programmed self-death process induced by Doxorubicin, is another crucial aspect. Resistant cancer cells downregulate apoptosis effectors and upregulate anti-apoptotic protein, creating a shift against self-death. This allows cancer cells to persist even in the presence of DNA damage. The epithelial mesenchymal transition (EMT) represents another phase of Doxorubicin resistance. Cancer cells undergoing EMT transform from a stationary epithelial state to a more mobile mesenchymal state, exhibiting reduced drug sensitivity and resistance to chemotherapy. An illustrative example of molecular mechanism underlying Doxorubicin resistance is observed in hepatocellular carcinoma. In this scenario, the resistance mechanism operates in the coordinate manner, creating a formidable defense against cytotoxic effects of Doxorubicin. The initial hurdle involved the reduced accumulation of Doxorubicin within cancer cells, facilitated by the upregulation of ATP binding cassette family efflux pump in the resistant cell. This impediment limits the concentration of drug within the cells, diminishing the therapeutic impact. Subsequently, Doxorubicin's interference with the repair of double-stranded DNA break generated by topoisomerase II is compromised. Resistant cells exhibit overexpression and mutation in topoisomerase II, enabling the continued function of enzyme despite Doxorubicin-induced DNA damage. As a consequence, apoptotic signaling pathways triggered by DNA damage are obstructed in resistant cells, leading to downregulation of apoptotic effectors and the upregulation of anti-apoptotic proteins. This intricate interplay of resistance mechanisms in hepatocellular carcinoma highlights the ability of cancer cells and the challenges in overcoming Doxorubicin resistance. In conclusion, the exploration of mechanisms underlying Doxorubicin resistance in cancer therapy reveals a complex interplay between therapeutic agents and the adaptive nature of cancer cells. Recognizing this complexity is crucial for the developing strategies that overcome resistance while minimizing toxicity. As we unravel the mystery of Doxorubicin resistance, we pave the way for a more targeted and effective cancer treatment, bringing us closer to a future where patients can benefit from the full potential of these powerful chemotherapy drugs in their fight against cancer. Thank you.